Hey, what is up everybody? It is Mr. Boylan. And today, what in the heck are we gonna do in this video? What are we gonna learn? We are going to calculate the concentration of a solution in units of molarity. I'm so excited. Now, the very first thing we're gonna do is define what the heck molarity is. Probably pretty important to know what it is before we try to do some calculations involving molarity. Second thing, we are going to calculate then the concentration of a solution in units of molarity. Okay, so first things first, when we talk about the concentration of a solution, essentially what we're talking about is how much solute do you have in a given amount of your solution. Okay, so it's probably easiest when you're trying to begin to understand concentration is to think about something or some context in which you already know, whether you realize it or not, that you're working with concentrations. And so I think something that we can all relate to is Kool-Aid or concentrations of drink mixes. And so if you take a look at your screen, you've got a beaker of pure water and there's no drink mix that has been added. Our drink mix is essentially going to be our solute, the stuff we're dissolving in our solvent, water. And so concentration is really, again, just about how much solute do you have in how much of your solution. Do I have a little bit of solute? Do I have a little bit more solute? Do I have a lot of solute? And we're gonna be working with adjusting not only the amount of solute, but the amount of total solution that you're working with. And how do those things affect concentration? Or how much solute do you have per how much of your solution? Okay, so let's tackle a couple of vocabulary words that you're gonna hear quite a bit. First, we talk about dilute solutions as those solutions that have a relatively small amount of solute in a given amount of solution. So if I come back to my drink mix water solution, if I have relatively small amounts of solute in my solution, I would say that that is dilute. However, we can also have what are called concentrated solutions. And in a concentrated solutions, conversely, you have a relatively large amount of solute in a given amount of solution. So coming back to my drink mix solution, as I increase the amount of solute in my solution, I would say that my solution gets more and more concentrated. I have more solute per volume of solution. Now, how are we going to tackle this in a quantitative way in the chemistry class? Well, we're going to use what's called molarity. It is the number of moles of solute per liter of solution. Oftentimes, we're talking about the solvent that's making up the other component of our solution as water. And so as you take a look at your screen there, you're provided that relationship that we see with molarity, the moles of solute per liter of your solution. This is not a formula that you have to memorize. It is provided to you on your formula chart. Now, before we look at a couple of examples, it's important to recognize that as a shorthand, we're often going to express molar concentrations by putting the concentration in brackets or by putting the formula of the solute in those brackets, just as a shorthand method to help everyone understand that we're talking about concentrations. So if you look at your screen there, you're given an example of the concentration of NaCl can be more quickly described as simply putting the formula for NaCl in brackets. And again, it's simply a shorthand method of saying the concentration of that sodium chloride solution. You'll often see us put the numerical value for the concentration in brackets. This often will happen when we're doing calculations involving the concentrations. Again, just reinforcing that we're talking about molarity or concentration. How many moles per liter are we talking about? Okay, now as fun as it is to work with drink mixes, let's take a look at some solutions that we'll more commonly see in the chemistry lab. The first thing to recognize here is that we're working with a copper 2 sulfate solution. We're going to throw in some numerical values so we can now better understand how we quantitatively would measure concentrations. Notice that I've got 1 liter of water. I'm going to add to that 1 liter 1 mole of copper 2 sulfate. Okay, so I have now created what is called a 1 molar solution of copper 2 sulfate. In other words, I have 1 mole of my solute, copper 2 sulfate, in 1 liter of solution. So again, I have what's called a 1 molar solution. Now, as you look at the formula for copper 2 sulfate, Recognize that the ratio of copper-2 ions to sulfate ions is a 1-to-1 ratio. What that means is the concentrations of the copper-2 ion and the sulfate ions are also 1 molar concentration. Because as I put this soluble ionic salt into solution, the ions dissociate into 1 mole of copper-2 ions and 1 mole of sulfate ions. Okay, we're gonna restart here with 1 liter of water, but instead of putting 1 mole of copper-2 sulfate into solution, I'm gonna put just 0.5 moles or half a mole in 1 liter. This would be a more dilute solution of copper-2 sulfate. Now, because I only have half a mole in 1 liter of solution, I've created a 0.5 molar solution. Again, because the ratio of ions is 1-to-1, when this soluble ionic compound dissolves in solution, I'm gonna make 0.5 molar concentrations of each of my ions. Okay, and I also want you to recognize that we don't have to use 1 liter of solution in order to calculate the molarity of this solution. So instead of starting with 1 liter, I'm going to use 0.5 liters of solution. And in this 0.5 liters, I'm only going to put 0.10 moles. So the concentration of this solution measured in units of molarity, or moles per liter, I've got 0.1 mole in 0.50 liters. Which gives me a concentration of 0.2 molar. Again, take a moment just to realize that the concentration of each of my ions in solution is 0.2 molar as well. Again, because the ratio of ions in the copper-2 sulfate formula is a 1-to-1 ratio. Always take a quick moment to check the info below the video to see where I pulled some of these great animations and simulations from. And we are done.